Hi, everyone. Welcome to OWASP Vancouver Chapter's June session. Today, we have two very special guests, Pablo Vidal and Don Burks. The first talk is from Pablo. It's on cloud security fundamentals, identifying and addressing low-hanging fruit. And Pablo is a staff cloud security engineer at Segment. He enjoys raising the cloud security bar while interacting and learning from engineers. Pablo is responsible for a pretty wide variety of tasks, including architecting security solutions and working with engineering teams to achieve least privilege while aiming for seamless improvements. Pablo, over to you.
Yep, thank you. Okay, give me a couple of seconds in order to share my screen.
And while Pablo is getting set up, if anyone has questions, please type your questions in the Zoom chat, and Pablo, I'll keep an eye on them, and then what we'll do is maybe either, would you like to answer the questions at the end, or would you like to have a pause in the middle? However you prefer, we can handle the question.
I mean, if it's okay, I would rather just do it at the end of the talk.
That sounds great.
Okay, that's good.
So if everybody could just type your questions on the chat, and then at the end we'll go through them, and we'll Pablo, I'll read them to you, and you can respond to them.
Thank you. Okay, let's get started here. Can you all see my screen?
Yes.
Okay, well, this is my presentation. I'm Pablo. I'm going to be talking about getting shit done. I didn't want to add this title to the abstract because it has the word shit on it. So this is what I'm going to be talking about. I'm going to be talking a little bit first about me. I'm Pablo Vidal. I've been working at Segment since November last year. It's been fantastic. I've been having a blast since I joined. And previously, I was a cloud security engineer at Synapse and also a security engineer at Hootsuite. When I started Hootsuite, that was like 5 years ago. I was just the general security engineer. It was a couple of years after that one of my colleagues pushed me to learn a little bit more about cloud security. And that's when I got hooked on cloud security, and I kept growing on that field up until now that I am working on a team of 3 cloud security engineers and really enjoying my time at Segment. This is the agenda. The talk will last about like 30 minutes, 25-30 minutes. I'm just going to give a very brief description on what cloud security is, and then getting into like planning, getting the stuff done, and a little bit of reporting, and then just touching a little bit on some AWS services that would be considered low-hanging fruit that could get that you could get benefits from with not a lot of effort. So what is cloud security? Cloud security just has to do with protecting the data on the application, the data applications like running on cloud infrastructure. Cloud infrastructure being AWS, GCP, Azure, on so many other different providers. So one of the main things that I do is focusing on getting deeper into, on this case, the AWS services, and learning the best practices and how to better support my organization to build stuff securely, and provided that bit of knowledge to the company. Cloud security also has a number of challenges. As you might imagine, cloud security and infrastructure, or SRE, are fairly close to each other. So when you join a new company, if that bridge is not just yet built, you do need to build a bridge with the infrastructure team. That team is going to be key for your success or failure in the company. And I've failed many times in the past when it comes to having a good relationship. Like, you don't want to end up in a situation where, hey, there is a lot of pointing fingers at each other saying like, oh, I'm being blocked, I can't ship stuff because you guys are blocking me, and the other way around, security and SRE are not aligned. And there are a lot of problems that could come from not having a good relationship with the SRE or infrastructure team. So you really need to build that bridge, and you own that bridge. So you have to be the one taking care of it. And then the other challenge on cloud security that I've bumped into is regarding planning or lack of. When you focus on when you plan for the year, or when you plan for the next 6 months even, you really need to put effort into what are the things that you're going to be tackling. Otherwise, halfway in, you're going to see that you're focusing on items that are not really priorities. And that happened to me a couple of times already, not while at Segment, but at my previous experiences. So getting into the planning phase, I really want to talk specifically on the way we do it at Segment. And I've found it that it's quite successful, actually. When you do the company, as I mentioned before, you want to do you want to engage with other teams first. That's the key for any kind of success you want to have in the company. And by engaging with other teams, I'm talking not only, hey, how are you guys doing, learning about their infrastructure, but also getting their input. Sometimes I've seen and I've experienced myself that, I don't know, we could think about SREs or engineers that, since they are not security professionals, they won't be able to flag what are the security issues or security concerns that they have, and that is totally wrong. Like I remember talking to an SRE a few months back when I started, and the SRE engineer was telling us, like, we were talking about something that he had to do in production that felt a bit not suspicious, but felt wrong to him, meaning that, look, I'm touching this piece of production data, and there is not enough logging, so I could be doing something malicious, and no one will let me know about it. Like, there is no audit log for this. So, like, that piece of feedback, it's something that might take me weeks to find out, and he is giving me that information. So I find it super useful to have them being the security engineers in a way and getting a lot of feedback, considering that they are the ones that know the most about the application or underlying infrastructure. One of the way we do things at Segment is after a couple of months where I was learning a little bit more about the infrastructure, all the different services, engaging with the teams, you get to a point where you could start thinking, how could my company be hacked? Because you already know some things, some possible flaws that you can find. So you could think about, okay, let's put all these scenarios together, and that I could think right now on how my company could get hacked. One example that I can give you, imagine that you have an S3 bucket that is publicly accessible and has AWS keys on it, and those keys grant admin access. So given that situation, we could give two metrics to that scenario. One would be the facepalm rating. But the facepalm rating is some level of how much shame would you feel if that happens to your company, you being the cloud security engineer. Or just to put it on a different way, imagine that you have a breach with that specific scenario where you had AWS keys on a public bucket, which is a bit of a shame. How would Twitter react to that? So you can imagine that it's also related with probably the security basics, getting those security basics in place. And that's where that rating from like 1 to 5 would be being 5, having an S3 bucket with AWS keys. And then the company ending scenario is another metric that we would use, and would be a metric that will change depending on the impact to the company. So we are talking about financial impact. We're also talking about brand impact or even customer trust. So having those two metrics really helps put into, like, just to give importance to a given scenario. Another example that I can give you is that just imagine that my company had IAM users, and IAM users were mapped to a human. So let's say that I have my own user, I leave the company. I had AWS keys assigned to my user, but those AWS keys were not removed when I left the company. And because of that, I am a bad guy, and the company gets hacked because of it. So the facepalm rating is probably pretty high, and it's also high risk depending on the level of access that I had with that user. Once you put together all these scenarios, let's say that you put together 7 or 8 scenarios, you want to share those not only with your peers within the security team, but also with the other teams you engage with. Just because they know more than you do about the infrastructure and application, and they will have a lot of valuable input on this. So we'll help you drive those scenarios as well, and even modify them based on what reality is for them. So you have the scenarios on one side. So the next step would be, let's create a project, and usually it's going to be a mapping, one-to-one mapping from a project to mitigate those scenarios or to mitigate that risk. The metrics that we will have on this is going to be level of effort. That just literally means how much effort it is required to fix this issue or this scenario. And then the risk mitigated, that will also map pretty well with the company ending a scenario metric that we had before. So, let's add projects to the roadmap. The way we are going to be prioritizing those projects within the roadmap is going to be by just sorting by risk mitigated minus level of effort. So you have, hey, enable MFA on AWS root accounts. The level of effort is literally just one click on the AWS console. And the risk mitigated, it's pretty high, considering that if you don't have MFA on AWS root accounts, you're literally one password away from a company ending a scenario. So the risk mitigated is really high. Whereas a totally different project, such as service-to-service authentication within your internal network, the level of effort is pretty big, considering that this is a project that may take like 3, 6, 9 months, and the risk mitigated, it's not that big, meaning that there is probably a lot more low-hanging fruit out there to be fixed. So these projects likely not going to, it shouldn't be going first on your list of priorities. So this is just an example of a roadmap that I put together since you see the security test Jira project. So like this is an example. Let's say that I put the scenarios together. Hey, what we should tackle first? Well, we should enable MFA on root accounts. This is something that literally takes 1 week or 2 weeks, depending on the number of accounts. Integrate AWS with Okta, just because we don't have a good process for onboarding and offboarding users on AWS, and then identify data on data stores with PII on the AWS accounts. A lot of things that don't take a lot of time to do and do have a good benefit and also mitigate specific scenarios. As you can see that at the bottom, there is the service-to-service auth. This is something that we are not going to be tackling on the first 2 months, just because it feels like we should be focused on something more important. And this goes back to is when you're working on something, you should feel that the work that you're doing is valuable, and you're not wasting your time, or you're literally missing out on things that you should be focusing on. So we are getting into the fun part, but it's just getting shit done. You have outlined all the projects, so now it is time to basically take them on. For this one specifically, the main advice that I can give you is iterating fast and just staying away from getting too deep into the weeds. Keep the solutions easy, and I'll give you an example of this. Something that we built at my previous company was an SSH Bastion host, which it was a great way to enable login for all the users that were SSHing both staging and production. So we had a central point for everybody to SSH in. We can handle authentication there. We had accountability, so a lot of things. But considering that this is a pretty sizable project, that it took about like 3 to 6 months to finish it. So when I'm talking about don't reinventing the wheel and staying away from rabbit holes, is that what I'm talking about is really, in this specific example, AWS Systems Manager already has an SSH solution. That I think that it came out last year. And with that solution, you don't need to implement SSH bastions, open network reports, or capturing session logs. Like Systems Manager SSH gives you all that by default. So before tackling a project, spend some time reading about it, reading all the possible solutions that already exist. And in the case of AWS, it is likely that that problem has already been solved and is a service. So let's say that you've tackled a couple projects. You're getting closer to your 4th or 5th month at the company. So one of the issues, and one of the reasons why I really like cloud security, has to do with finding new fires. So you get to know more, but you're also going to be finding issues. And I actually have an example that I experienced a few years back, and it's that I joined the company, and then like 3 to 4 months after, I realized that engineers on a regular basis will will clone production databases locally to do local testing. Considering that we had PII on the system on those databases, well, that was a pretty big fire. So the approach that I think that it makes sense, and the approach that we take at Segment is, okay, you see a big fire. You really want to drop everything you're doing and get into that fire right away and address it. So the way we do it is just, let's time box that. You do some kind of a spike. So you time box the exploration time that you're going to be spending on identifying the issue, learning more about it, and even grasping possible solutions for it. So you're going to go back to your scenarios. You're going to create a scenario, and then you're going to create a project to mitigate that scenario. Then with that project, you're going to have a level of effort, and you're going to have a risk mitigated. So you could literally get a number that you can then place on the world path, depending on how long that it would take to build something like that, or in order to address that issue. And then this is also a bit similar. It's regarding not going deep. And I'm not saying that you don't need to be technical, or that you shouldn't learn more of a specific service, but it just has to do with like knowing what is good, and knowing what is good can be actually tied back to the project. So whenever you create a project, you're mitigating on a risk, but you also could have some kind of criteria for what success looks like, where you know where to stop. Something that I was doing a couple months back, it was regarding a specific S3 bucket. So we have an S3 bucket that had critical information. So I took an iterated approach in order to secure that bucket. So the first thing that we do was, okay, let's look at all the IAM users and all the IAM roles that have access to this bucket. So we did that in like a week or two, and we make sure that we were following this privilege and that. We were like, okay, this is good. But then we thought, oh, well, we could also look at like S3 bucket policies. And well, with S3 bucket policies, you can really tighten things up, just because you can literally have an allow list on that S3 bucket policy where you say, user A, B, and C can access, but no one else can access. So that way, instead of relying on IAM, on policies that are attached to IAM roles or users, you literally say on the S3 bucket policy who can access, and those are all the entities that get access to your bucket. So we did that. So we said, okay, that's pretty good. But then I kept reading about it. It's like, look, what if we do like S3 access points? Oh my God, what is S3 access points? Well, S3 access points is just a new endpoint that you could have for your users to access a given S3 bucket. So I thought it's like, look, we have S3 access points for each one of the users. And even you can go even deeper and limit them based on the VPC endpoint they are coming from. So like, you're gold if you do that. So that's when my manager came in. It's like, wait, Pablo, like, are you like, is this approach that you're taking, is it worth your time? Like, what is the risk that we are mitigating here? And like, you have to sometimes take steps back and be like, okay, is what I'm fixing right now good enough? Because like the time that I spent looking for access point was great, but it was probably worth, hey, take a step back, create a scenario, create a project, and probably based on the rating that has, delay that to the end of the year, for instance, but not tackle it right away. I also want to talk a little bit about reporting. That's something that I've struggled with quite a lot in the past, just because on cloud security, you're going to be touching a lot of different pieces, from, hey, MFA and root accounts, to scanning AMIs or like Amazon machine images or like enabling S3 access logs and creating CI pipelines. So a lot of different things. So how do you talk to a non-technical people or non-technical person and tell them, hey, this is the impact that I've done, that I've made. Like this is the benefit that I've brought to the company. It's quite difficult to put that together. So that's why I really like relying on, hey, let's go back to the scenarios document and the roadmap, and both technical and non-technical people can really see the impact that you've made based on the scenarios that have been mitigated with the things that you got done. And this is my favorite slide. This is about side effects. And like, again, one of the reasons why cloud security is great. You do have a lot of freedom on cloud security. You can literally like spend half a day just in a way. I know that I'm contradicting myself by saying like chasing a rabbit hole, but like you could literally focus on new services, new things that are coming, and like on even the state of art for the company and the services and how the services are used. Like you could really spend a lot of time being like, okay, we could do this better, even though it's not security related. But all the knowledge that you've gained on the how to use those specific AWS services in this case, that knowledge could be leveraged by other teams. So I don't know, like I remember back in the day, like talking to one engineer that had a workflow where he was cloning a production database using the AWS console and then deleting it, but he forgot to delete it. So I was like, wait a second. Why don't we migrate this to like Terraform? And then we had an automated workflow for creating that, testing, and then deleting the database. So I am somehow addressing a security issue, but it just has to do with helping others and also building relationships, because those relationships are the ones that they are going to use for, hey, this is something fishy. This is something that doesn't feel right. Help me out with this. That way I can learn more about their use case and understand better the way they work and how can they be helped. And also, well, we are in COVID times. Companies are trying to save money. So I don't know, just by reading a little bit about S3, it's like, oh, there are so many things that you can do in S3, like applying lifecycle policies. And there is not really a person that is in charge of, hey, let's focus on all the S3 buckets that we have. Considering that you are working on cloud security, you already have a lot of access to a lot of things. So leverage that to make positive impact in the company, even though it may not be directly related to security. So wait, we actually use the lifecycle policies to save some money, and like other things that you can do and iterate on that will help others, will help in building those relationships. And also like, yeah, turning off obviously legacy systems also helps. But again, just because, hey, you have access to a lot of things. So you can literally help others just by leveraging that level of access that you have, plus the trust that you get by building those relationships. So I'm just going to go through a number of low-hanging fruit examples. If you're already good at AWS, you're going to be probably disappointed, but this is it. I'm going to talk a little bit about S3. S3 is one of the first services that AWS put together. It's awesome. It's one of the best services, and well, in my opinion. And like there are like just 3 things that you might not know about that are actually super useful that didn't exist like 5 years back. One of them is just S3 bucket policies. Like the best thing about the S3 bucket policies is that it allows you to be certain about the entities that are accessing your bucket. And that is super useful. Trying to control all the IAM policies that are created across an AWS account is actually fairly difficult. So it's not straightforward to know what are the things, like to have a dynamic inventory of things that have access to your bucket. So put that weight, instead of on, hey, let's chase for policies that have access to the S3 bucket, let's put that weight on the S3 bucket policy that is just resource specific, and that way you can really limit the entities that have access to your bucket. Specifically on S3 lifecycles, that's something that I've mentioned before. But a lifecycle just has to do with, let's say that you have a bucket for logs, and those logs are usually not used after 30 days. You can set a lifecycle policy that deletes those objects after 30 days. Or you could even do transitions on S3 storage types. So something from S3 standard, you're paying, let's say, $1 for a terabyte. But if you transition that to infrequent access, you're saving 40%. If you transition that to S3 Glacier, no, it's not S3. It's called Glacier. You'd be saving 80%. So there are a lot of things that you can iterate with that would help also to save money. Specifically on S3 access logs, actually, let me take a step back on this. AWS CloudTrail is the main logging platform or service for AWS. So AWS CloudTrail will get all the logs for all the management events. Something like, hey, create a bucket. Hey, create a role. Hey, create a policy. But it doesn't give you information about data plane operations. Why? Because there are just too many. There are S3 buckets that have thousands of operations per second, so it would be impossible for CloudTrail to keep up. So there are two different options here in order to have visibility on who's accessing my S3 bucket. That's something that from a security perspective, you probably want to know on buckets that are critical. So you can enable S3 access logs or something that is called CloudTrail object logging, that will do more or less the same. CloudTrail object logging is a lot more expensive, just be aware. But S3 access logs will do something similar. It would just log everything that, all the access attempts or all the successful actions on the data plane for that S3 bucket into another bucket, and you can parse that. And probably the incident response team will be very happy with those logs. Just talking a little bit about IAM. IAM is the key, and it's basically everything that has to do with access and identity management. And I can just give you a couple of examples on like, really what you have to think is like, how are engineers interacting with AWS and how are services interacting with AWS? At one of my previous companies, like we had IAM users. So again, as I said before, Pablo had its own user. So the IAM user Pablo existed there. The problem is that some of the engineers for some of the workflows that they have were copying their IAM static keys to the production servers in order to perform actions. That is not great. So you really need to think on how are engineers interacting with AWS, and like, is there anything that I can help in order to prevent those use cases from happening? Or another situation that we have that we had at also in a previous company. It was regarding we had IAM users for services. So with the static keys, it's not great, I know, but well, we were not fully into using IAM roles and attaching them to services. So we had static keys that were used by services, right? One of the problems that we had, even though those keys, that access key ID and secret were stored safely, securely on, I don't know if it was secrets manager or SSM parameters or HashiCorp Vault, something like that. So they were properly stored. The problem is that they were sharing the same key. So it was really difficult to have accountability on what is one service doing if they are using the same AWS keys. And then the last one is just a service that came out a couple months ago that I found awesome and something that we struggled with in the past. That is, if you have an AWS organization that has several AWS accounts, you could deem that, or those accounts on this organization as a trust zone. So any resource that is shared within that organization, you could deem them as, hey, this is fine. There's nothing going wrong. So what IAM Analyzer is going to do, it's going to be looking at all the trust policies for roles, S3 buckets, SQS, Lambdas, and IAM roles, and let you know if there is a new share with any entity outside your zone of trust. So let's say that I create a bucket and flag it as public. So I enabled public reads on that S3 bucket. IAM Analyzer is going to fire an alert. Let's say that I have a role, an IAM role that has admin access, and I'm sharing that with my personal account. IAM analyzer will send an alert. So I find that super useful and something that I personally struggle with when it comes to how do I analyze the trust policies for all the roles that have been created. Then moving into EC2, if you look at the API for EC2, you're going to be overwhelmed right away. EC2 is huge, and the documentation is great, but it's also huge. But one of the things that I usually do when I join a company, it just has to do with, hey, let's list all the EC2 instances, RDS databases, load balancers, and Redshift databases that are, Redshift clusters that are exposed to the internet. And the good thing about that is, well, you are gonna get some learnings from it, but it's a great conversation starter with other engineers. Whenever you see an EC2 instance that is publicly accessible, you're probably gonna be missing a lot of context. So it's a great conversation starter to be like, hey, SREs, like, what is this instance? Tell me more about it. What is the use case? And that applies to all the different services that could be exposed to the internet. So it's just a good way of having a conversation, learning more about the system, and also, well, it is likely that you're going to be finding some issues with it as well. So that's something that can feed back into your scenarios document as well. And the last one is just AWS Guard Duty. I think that it came out like 3 or 4 years ago. What AWS Guard Duty does is basically generate alerts on flow logs plus DNS queries plus AWS CloudSec logs. CloudSec logs are the AWS management events. DNS queries are all the queries that any instance makes. I'm actually not sure if Lambda does the same queries. I think that it should also capture DNS queries for Lambda. And then the flow logs, that it's all the network traffic logs on a very specific format. Parsing those flow logs is actually quite challenging. So by enabling Guard Duty, you're going to have some good level of visibility, or at least some level of trust on, hey, if there is something going wrong in my AWS account, I'm going to know about it. One example that I can give you is that, remember back in the day, one junior engineer had was testing on a dev account and spinned up an instance with a Jenkins instance that didn't have any, I think that it had the default credentials. And just with the default credentials on Jenkins and publicly available, well, that ends up being a clusterfuck. Sorry for part of my French. So, well, that instance got popped. So if we didn't have Guard Duty enabled, we would have known. I mean, it's not a problem just because we were lucky that that AWS instance didn't have a role associated that would grant them admin credentials. If we were, then instead of having only that Jenkins instance mining Bitcoin, we would have 2,000 instances mining Bitcoin. That would have been a bigger problem. So that's why I think that no matter how big your security team is, if it's only you, still enable it. Just because it will give you some level of trust and comfort even on, okay, I think that I know more or less what is going on in this AWS account. So just to wrap things up, spend enough time planning. I know that it can sound boring at first, but really spending time on putting together the scenarios and iterating on those is really useful. And also leverage all the freedom you have to help others. As you learn more, like, you're really going to have a chance to make an impact outside your security team. And that feels good. And then also go broad. Don't get too deep. Don't do as I did, getting super deep into S3 and like, oh my God, we're going to do S3 access points. It's going to be awesome. And then people were like, look, we have other fires we need to focus on. So go broad and touch as many things as possible in a way. So you'll find a lot more fires that need attention. So just wanted to share a couple links. As I mentioned before, when I was at Hootsuite, my coworker actually told me, hey, you should learn more about AWS because you have no idea about it. So I started learning using Cloud Guru, that is a platform with videos for AWS certifications. And I'm like, to this day, I'm still using it because I think that that's a great resource. That and AWS documentation that I think that is fantastic. Also added a link to segment.com careers. This is the best company I've ever worked for, so you probably want to check it out. It's only my opinion, but it's one. And that's it. Thank you, obviously, to the Segment Security team. They had to go through a number of dry runs about this talk, and it's much better than it was before. So yeah, just connect with the Segment company on LinkedIn or FMD. Thank you.
Awesome. So thanks very much, Pablo. We've got time for questions and answers. I see there's a couple of questions on the chat. First one is about cloud security hardening. So how do we go about cloud security hardening? The person asking the question is saying that they're currently speaking about policy and compliance from a security perspective. They're using the CIS benchmarks. So are there other resources as well in terms of hardening AWS security or cloud security?
That's a really good question. AWS has a number of services that will help you on that. I think that one is Security Hub that would actually allow you to focus on a specific framework. And then the other one, I think there is AWS config. You can use AWS config for setting specific restrictions, not restrictions, but setting something that will be resource compliant. So it's some kind of like template or, hey, I want all the resources to have this, or I want all those security groups to have that. Then you can get that with AWS config. And I believe that Security Hub is the best tool for adjusting to a specific framework. I could be wrong. Only use it once for a week.
That sounds good. I think, and the second question, thanks very much, Pablo. The second one is the AWS Security Hub services, are they able to pull the information from exposed data on the internet? Does that make sense? So it's from
I don't know enough. To be honest, I don't know enough about Security Hub. I've only used it for a week and then threw it away. I don't think that you can get that information from Security Hub, but I'm not totally sure about it. Specifically for exposed services, that's something that, to be honest, is still a challenge. It's kind of surprising that after AWS has been like out there for so long, there is no specific service that will let you know right away, hey, these are all the endpoints that you have exposed, or these are all the ENIs or Elastic Network Interface that are exposed to the internet, that have a security group attached to it that is publicly available. You can look, if you have a multi-account scenario, I think that the AWS Firewall Manager, they just released it not long ago. It works for organization. It allows you to centrally manage security groups from an organizational level. So it's like setting templates for security groups in a way. Again, do some digging on that because I'm not totally sure about it.
Yeah, and I think the gentleman is asking a follow-up question. They're talking about the misconfiguration in particular for like Git or Bitbucket repos. From my understanding, it doesn't do that. Like you'd have to use different tools outside of the AWS environment to
I'd say so.
Get exposure on those. Yeah, there are tools. I can't remember any offhand, but there are tools that can scan your repos and look for sensitive security data. You know, if you're putting something in there that's a credential or something else sensitive in your repos, that it could alert you on that. But AWS tools don't do that. The other question is, any idea on serverless architecture and API security integration with Okta? I'm not sure if that's within the context of this presentation, but probably you can have a crack at it if you'd like.
Yeah, I mean, specifically on the integration with Okta, I mean, first of all, I've heard the word serverless. I'm in love with Lambdas. I use Lambdas for everything. I know that they're probably not great for a production fit on most use cases, but still, I love them. Moving into the Okta part, I think that like 3 weeks ago, AWS released something for integrating with Okta. It's called AWS SSO. I don't know if the question goes on that side. Like, I don't know where the matching is from serverless to Okta. If they can clarify that, that would be great.
And thanks, Pablo. And the final question there is, any specific advice regarding taking your CI/CD pipelines to AWS?
Say it again. Sorry, I can read it myself. Sorry.
No. It's any specific advice regarding taking your CI/CD pipeline to AWS?
That's a good question as well. I know that like AWS has 3 services: Code Commit, Code Pipeline, and Code. I forgot the last one, that are used for CI/CD pipelines. As for migrating those pipelines into like EC2 instances, I can't provide enough advice just because I haven't set pipelines myself using AWS services. All the knowledge that I've got from, hey, those are the services that I use for CI/CD pipelines are from actual AWS certifications. So again, sorry to disappoint, but I'm probably not the best person to talk about CI/CD pipelines in AWS.
That sounds good. That sounds good. Thank you very much, Pablo. Really appreciate it. Big round of applause, I suppose, for you. I mean, we're not very person to do that, but thanks for the talk. It was very informative. So welcome to the second half of the OWASP Vancouver June meetup. Our next speaker is Don Burks. Don is going to talk about GraphQL security, topic that I'm very much interested in because I don't think it's talked about often enough and there's not enough knowledge amongst the community. So this is great. Don is the technical lead at Sphere, formerly the head instructor at Lighthouse Labs, senior developer at Metro Lyrics, and subject matter expert at Microsoft MSN. He's also a published author, international speaker, an accomplished musician. Love that. He has led a national campaign to bring computational thinking and coding into public education and is a strong advocate for application security. His blog can be found at donburks.com. And Don, I'm going to give you the sharing, so go ahead and share your screen, and without further ado, Don Burks.
All right, thanks so much, Farshad. So there we go. Everyone should be able to see my screen now.
And Don, we'll leave the questions to the end. People can type their questions in the chat, and then Don, at the end, I can read them out.
Perfect. All right. So GraphQL security. I'm going to go through this with some assumptions. One is you've already been introduced to me, so I don't need to linger any time here on my big fat head. And here's the other assumptions. You understand what GraphQL is and isn't. If you haven't had any experience with it, there will be some links at the end that you can explore. The short, very short kind of elevator pitch for GraphQL is that it is a new API methodology that replaces our good old friend REST and is really about using a structured data language to allow front-end clients to request data in the shape that they need it without having to do multiple REST queries to be able to fulfill relational data requests. So another assumption is that there may or may not be an implementation of GraphQL in your near future or in your present. And of course, because we're at OWASP Vancouver, another assumption is that AppSec is something you know is important. So I want to start off with this quote. I grabbed this quote from Twitter and completely forgot to attribute it. So if anybody remembers who it is from, please feel free to correct me later. The quote is, just because it is new, that does not mean that it is secure. And the reason I bring this up is while GraphQL as a public project is 5 years old now, it's only really started to come up as a mainstream technology and protocol that's being used in the past 3 years roughly. Facebook developed it and they've been using it all the way back to 2012. 2012, the web interface of Facebook was actually using GraphQL behind the scenes to fetch data. So it is production tested, it is tried and true. It is also now open source with an open spec. And if you don't believe that new is secure, or if you think that new is secure, just ask the MongoDB community. They, a couple years ago, had an entire omelet on their face, not just a single egg. Couple big categories that I want to talk about when it comes to securing GraphQL. And when I'm talking about these things, I am 100% talking about it from the back end side of the equation. The front end, the client side, is typically simply requesting data as any other API client would. And short of if you're using like a specific API key and that's visible in your front end, that might be a way that, you know, there's a security issue there. But honestly, about 999 out of 1,000 issues that you're going to run into are going to come on the back end. So big categories, I want to talk about changing the route that most people use for GraphQL. I want to talk about one of the GraphQL features called introspection. I want to talk about using authentication with GraphQL. I want to talk about monitoring and measuring and limiting the depth and complexity of your GraphQL queries. And last but not least, I want to spend some time talking about schema generation, because there is a lovely movement in the GraphQL community to make it easy. So let's talk about route changing. Many things we do as developers, especially in web technologies, are conventions. They are not requirements. There are a lot of things that we do simply because it's been done that way for the past 20 years. And sure, there are alternatives, but everybody knows and expects X. Well, we don't have to necessarily do that. The industry standard is to have all GraphQL queries going through a single endpoint that is /GraphQL at the end of whatever your API domain is. This is a convention, not a requirement. It's been adopted as the go-to endpoint for all GraphQL implementations, and this puts a great big bullseye on this route. In fact, I will tell you that we did a production deployment twice today in Sphere, and interestingly, after the second one, for no apparent reason, we saw a sudden spike in hits to our /GraphQL or to a /GraphQL endpoint, and they were all coming from overseas, and they were obviously bot hits. So there are bots that are now starting to hit /GraphQL as a target. And because my sense of humor is entirely what it is, and I make no apologies, I will recommend as an example that you could change your GraphQL endpoint to /FluffyBunny. Not a standardly enumerated route, works just as well as the default because the backend server doesn't care, because most likely your Express, your Laravel, your .NET server, whatever you have running that is handling the web application part of your backend is what is going to be processing this route and handing off the request to the GraphQL engine. So the GraphQL engine does not care what the route is where it comes in. It could be /avocado, /whatever. I've seen some people just reduce it down to /GQL, which of course is security through only slight obscurity. But yeah, neither the client nor the server is going to care what route the request comes in on, as long as it is a well-formed request. So if we were to do /FluffyBunny, you want to trust the bunny, because the bunny is where all your data is going to come from. Another route that is an issue is one that is called /GraphIQL, and a lot of people pronounce it graphical. This is a sandbox that comes shipped by default with all backend GraphQL engines that allows you to test your GraphQL queries against your schema, which is great and fantastic if you are in a development environment or a testing environment. But if you are in a production environment, giving your less than savory visitors a great big lovely web dashboard where they can discover your entire schema for your application and pull all of the data that they can get access to is a really bad way to do things. A lot of the major packages now have finally taken the step of disabling graphical in production. But I actually recommend disabling graphical in all environments. If it's just disabled by default in the way that you deploy the code in any environment, then you can use other tools. There's a great Electron app that is basically a copy of the graphical environment that you can install and use. And if any of you are familiar with the Postman competitor called Insomnia, you can do GraphQL queries there. And I heard a rumor, although I don't use Postman anymore, I heard a rumor that Postman will ship GraphQL queries now, so you can do them in that tool. So use another tool that you would normally use to test your API and use that to test your GraphQL queries. Don't leave the web sandbox enabled at all. It's just because basically the reason I say not to leave it enabled is as soon as you leave it enabled in one place, you're going to forget. And if you have it disabled in all environments, you're covered. Second thing I want to talk about is a feature of GraphQL called introspection. It is great when you're developing alone, and it's not so great when you're standing in front of 7 billion people. And I was talking to another GraphQL dev a couple months ago, and he gave me the greatest analogy for this. So I want all of you to avoid the PTSD and cast yourself back to high school, where when you had a secret and you walked into a room, you were convinced that that secret was doing a marquee across your forehead and that everybody could see it and everybody would know this bad thing that you did or this secret that you were supposed to be keeping. Well, we all know from life experience that that's not actually the case. And unless you walk into a room looking guilty as hell, no one's going to know what's going on. Introspection, though, is like having that marquee going on for the schema of your GraphQL instance. What introspection is a specific type of query that can be sent to your GraphQL server that will return the entire schema for all of the node types and all of the connected edges for all of your data types that you have defined, which get called type definitions in structured data language. And they basically, that way a client like Insomnia or like the graphical IDE can load in your entire schema and validate things as you're typing to give you that, IDE kind of experience. So I encourage disabling introspection in your testing and production environments. In development, this is one of those cases where in development you kind of need it, especially if you have a very distributed team. And let's face it, in these unprecedented times, who does not have a distributed team? That way, a new person on the team is able to query the schema unless you have the best documentation of any dev team ever. And there's, of course, a constantly updated wiki that can be accessed that has the full definition in it. That way a dev can query it and get that schema for their local development, but disable it in your testing and production environments. In fact, I will tell you that I go so far as to specifically write a unit test that double checks that the introspection query is disabled in my testing environment. And if that fails, then nothing ever ships to production. Apollo and Fastify GQL, which are two of the bigger backend JavaScript servers, they now do this by default. Prisma, I'm also finally happy to say, is doing this by default in production. Yeah, like I said, test for introspection leakiness in your testing environment. That way you can guarantee that nothing is shipping with introspection enabled. Authentication. Having consulted with a number of companies that have started to use GraphQL over the past couple of years, and I've been using it myself since November of 2017, I guess. And so I've had the opportunity to talk to a number of companies over the past 2.5 years that are starting to implement it and have come to me for advice. And this is probably the area where I see the biggest mistake in new GraphQL implementations, which is not connecting your authentication to the resolvers that are processing your queries. For those that are new to GraphQL, when a query comes in, whether it's a query to get data or a mutation to change data, there is what is called a resolver, which is basically, if you're in your MVC kind of world, your models are your type definitions and your resolvers are your controllers that actually do the work of building the data to send back in response to the query or the mutation. And so in the resolvers, you want to bring in your authentication in some way. Most commonly now with GraphQL APIs, I'm seeing a lot of JSON web tokens being used. I know many of you, from seeing familiar names and faces in the participants list, have opinions about these. They can be done well. They can also be done really poorly. But the nice thing about JSON web tokens is if they're passed in the authorization header, they can be checked at the context level with each query so that you can verify with each level of query that you have that the user that's making that query actually has permission to make a query to your API at all or to that section of the API. And then you can also go into the authorization phase and make sure that that user has permission to query for that particular resource. just like you would in a REST API. The rules haven't changed, just the beat that we march to. That's the only thing that's changed, but you're still drumming. ACL, good old-fashioned access control, means that admin queries are going to be restricted to admin accounts. It means resource ownership and edit privileges are checked before you ever serve up data. I've seen so many times where companies are starting to implement GraphQL and everything is open to everyone. Even things like the users table, where you can end up returning somebody's password digest, even if it's salted and hashed, in a query because somebody didn't have a good implementation, didn't check to see if it was the right user ID making the request. Some really basic stuff there that you would want to build in at the code level with the resolvers. And I want to talk about edges. So one of the terminologies you get in a lot of GraphQL is called nodes and edges. And so an example of a node is a user. So if I'm querying for Don at don.don in my API, that's a node because that's a unit of data. That generally a node maps to, say a row in a database table or a document out of a NoSQL database. Edges are the data that is related to that node. So if we were going with the standard blog context, as a user, as a node, I would have an edge that would go to posts that I have written. I would have an edge that would go to comments that I have written. I might have an edge that would go to tags I have created. I might have an edge that would go to likes or reshares or some other casually gamified social media action that I had done. Basically anything where there's a finite unit of data that is directly related to, in our SQL foreign key kind of thinking, to that original node, that's an edge. And so with all of your edges, don't forget to add authentication and or check ACL in the resolvers that facilitate the edges, because when GraphQL is servicing that query, I can request a specific user, and in that same query, I can request all of their posts, all of the comments on those posts, and all of the likes on that post, for example. So that's a node going to an edge for all the posts, and then from that post, each post is a node, which then has an edge out to a comment and a like, or comments and likes, for example. And if I'm not validating at each one of those steps in each one of those resolvers that the original user making the query has permission to fetch that resource, I'm leaving the barn door wide open and hoping that cows don't get adventurous. It's not going to be a good secure application. So these are things that you have to think about with multiple layers of ACL and authentication in your GraphQL app. And it's one of those things where, just like if you were building a REST app, once you get into the habit of it, as a developer, I can tell you it honestly becomes muscle memory. Every resolver you're going to write, you're going to check permissions, you're going to check authentication, and see if it's in the right place. So here's an example of a type definition. It's a user ID, email, username, admin, created at, updated at, last login. Standard bits of data that we might want to query about a user. One of the nice parts about this with GraphQL, and the reason I bring this up, is because when we're talking about authorization and access to resources, you'll notice that if you were constructing a user in your database, there may be a number of other fields that you're going to have in there. I referenced, say a password hash or password digest earlier that I'm not exposing here. So this is actually a layer of security within GraphQL, is that I, as the schema designer, get to determine what data I'm going to expose to the outside world, even behind a layer of authentication. So if I'm making all of my users publicly accessible, I need to be really careful and really critical with this type definition to determine what it is that I'm going to allow to be fetched. other thing that you may have noticed there is I've got some keywords like string, Boolean. ID is a special type in GraphQL that represents an integer, a non-zero integer, in fact, a positive non-zero integer if you want to get really specific. So I'm even able to validate the schema from a data type perspective on what's going to come back. So that means my front end knows that it's never going to get an email back that is a unsigned int or something like that. And on the right-hand side here, we've got another type definition for a post. And again, there may be lots of other information about this post that's out there, like whether it's a draft, whether it's been edited, who the last person that edited it was. But that's not data that I'm exposing through this type definition. This is all the data that I want my application to be able to show for each post. You'll also notice that there's an author type here that is returning a user data type. This is where the magic of GraphQL comes in, is our ability to use type definitions to create relational data and build a multi-dimensional complex data object to return to a single query. But if I am a user that is querying a post, and that query includes returning information about the user, I need to make sure in writing my resolvers that the data from over here on the left that I'm returning is data that that user that originally queried the post is entitled to see. If it's not, I need to be filtering that out, or I need to reconsider my schema. And here's, a JavaScript example of the type of resolver function that would handle this. So here's our post category, and here's the author key that I have defined. And I'm going to return some select star from users where ID is the author ID on the post, limit 1, because there's only, generally one author per post. And in doing so, I've effectively returned everything. GraphQL is going to take the nice layer of only returning the things that were defined in my type definition. Even though I have requested all fields, only the ones that I've defined in the type definition can come back. So that's a built-in layer of security in case you oops and don't write a better select query. Pro tip, write a better select query for something like this. And if I was going to be bringing in some authentication and some, authorization checking, I might bring in things like from the context of the query, which is where I would stuff authentication information that came in through like an authorization header with a JSON web token. Is the user that's in the context, are they an admin? Is the user ID that's making the query the same as the author ID of the post? If it's not, then I'm not going to return anything, or I might throw an error, or I might, return a string that's an error message or something like that. If those conditions pass, then I will do that query and let the data filter through. Because then I know that either the user's an admin and therefore entitled to see it, or that this is the user that controls that user record, and therefore they're entitled to see all their information anyway. Next category, depth and complexity. It is easier than you think and is also simultaneously more important than you realize. So the depth and complexity is where DDoS attacks come in with a GraphQL server. There are different types of complicated queries. Depth is one, which is the number of edges your query is trying to access. Too much depth can DDoS your server due to overloading memory, overloading data store. If you have, oh gosh, let's say you've gone really terribly and put a SQLite server behind your application, and all of a sudden, 169,000 queries are hitting it at once, and performance is affected. The depth is what would cause that, and I'll show you an example of a deep query in just a moment. The other one is complexity. Some queries may have extreme complexity to them and should be evaluated accordingly. This involves queries doing heavy joins, aggregations, or especially if you have anything that is retrieving data from an external API, and therefore you are dealing with, for example, asynchronous traffic. Another great example of this is, let's say that you were doing a mutation, so you were changing information on the server, and it's a user that is updating their avatar, and you are sending it off to your image service to be crunched down, and to have the right, size and resolution of avatar generated and then pumped out to your CDN, like the S3 buckets that Pablo was talking about earlier. That's going to take some time, and you're not going to be able to immediately return that query. So somebody who maliciously sends through 25,000 avatar uploads just to, have some fun with you is probably going to do some bad things to your server when that happens. Here's an example of a deep query. And one of the kind of built-in gotchas of GraphQL is that you can have cyclical queries. So here I've got a query where I'm querying for users, and this is basically, we can assume here this is querying for all users in my database. For every user, I want all their posts. For every post, I want the user that wrote it. For that user, I want all their posts. For each one of those posts, I want the user that wrote it. For each one of those users, I want all their posts, et cetera, et cetera. And then finally, like 8 layers down, we'll just return the ID. And this is just the screw you portion of this query. Depth of these queries is too damned high. The good news is there are plenty of libraries and plugins for every modern flavor of GraphQL server that will monitor the depth of your query and allow you to set a threshold. To give you a little bit of math as to why this gets ugly, in case you haven't already done it in your head, let's say that I'm doing a query and I'm going to keep it nice and simple, and I'm just going to request the first 50. The first 50, that's not a GraphQL convention. That's a param I would have defined as a developer to say that, I'm going to have a limiter on my queries. And for each one of these users, I want their last 10 posts. So I want to see the 10 most recent posts that they have sent. For each post, I would like to get the ID, the title, and the body. Well, that's 50 nodes of users. And for each user, we're going to be requesting 10 nodes across the edge, which is the post. So that's 550 nodes overall. So let's say we monkey with our 0 key just a little bit on the keyboard, and now we're taking the first 5,000 users. Let's assume you have a service with 5,000 users. If you do, congratulations. And for each one of those 5,000 users, we would like to get the last 100 posts. So there's 5,000 nodes of users and 100 nodes for each user. And we now have 505,000 nodes that have to be queried and returned. And anything in the resolvers that is going to be doing data sanitization, markdown compilation, image modification, XML formatting, zipping, unzipping, anything like that. That's all going to affect this. So this is why we want to monitor the depth of the queries. 5 is my magic number. If your query is deeper than this, query depth is not your biggest issue. And the reason I say that is because if you have a data schema where you are having to go more than 5 levels deep, it's probably going to be a reporting query, and there's probably a better way for you to structure that in the first place, unless you've just got something that's so gross and has like 86 joins in it or something just really ridiculous like that. And then it's actually possible on a per query basis in the context to allow certain queries to have a higher query depth, depending on which backend software you're using. But for most, I would say, consumer queries, you're never going to need more than 5 layers deep of nodes and edges. Last big category I want to talk about is schema generation. And this is my quote here. Hey, this is so cool. It hacked my site for me. The reason I bring this up is because there's a number of the Fisher-Price level of intro to GraphQL wizards that have been built, where what it does is you give it your database credentials, and it goes and analyzes the schema of your database and auto-magically builds you an entire GraphQL schema that you can now query and see how great it is to query your data via GraphQL instead of using primary SQL. If it seems magical, it's probably dangerous. And we know this very well in security, that as soon as someone's says it's a one-click solution, you know that that's not where your budget really needs to go. So it is one of the most dangerous approaches to implementing GraphQL, especially if this is something you're going to do in production. If it's what your team is doing to kick the tires and you just want it to auto-generate the schema, and SDL is the structured data language, it's great. If you just want to get familiar with how it feels to make GraphQL queries, how to add authentication to it, if you want to see how well your front end responds to getting data with just one request instead of 5 at a time, yeah, those kind of wizards and generators are fantastic. Unfortunately, really what those wizards are designed to do is they're just designed to give you a CRUD app with GraphQL instead of a CRUD app with REST. So they aren't actually implementing GraphQL for you. They're just translating one schema into another. But they are great for, okay, I've got a weekend, I'm going to go through a tutorial. I saw this bald guy talk about GraphQL, sounds really cool. I'm going to kick the tires a little bit. So tools like Prisma, they're fantastic for doing that. But I wouldn't, the latest version of Prisma, I don't want to talk bad about it, because the latest version of Prisma is actually pretty impressive, and they are working very hard to give a backend server that can be used in a production environment and doesn't use as much magic as the original versions did. But please don't ever use in one of these query generators for getting into production. Even if you have a very large schema that you are going to be working to translate, do it in batches. Literally build it into your sprint planning, that part of every 2 weeks is sitting down and writing some data schemas and testing them out and building some resolvers to service them. Usually GraphQL is something you can roll out side by side with REST because the GraphQL has its own route /fluffy bunny. These kinds of generators I call REST with sprinkles, because that's really all they've done. Design your SDL schema, don't generate it. And generally what I recommend, I always recommend storing your data in the way that you're going to query your data, and this follows for schema design as well. So look at what your front-end requirements are and look at how you query and how you post data from your front-end API clients. That is going to be what dictates what your schema needs to be, and where the opportunities for improvement are. Because if you have a workflow and a data flow in your front-end API client where you are having to do 2 or more queries to satisfy one particular data view, you can probably reduce that down to a single GraphQL query using nested schemas and the nodes and edges. And so you're going to start off with your SDL, your type definitions, your structured data language like the user and post that I showed earlier. Then I generally recommend, and I've had a lot of success with this myself, I recommend designing your mutations next. Design the schema around how you are going to change your data. What parameters need to be sent in to reset a password? What parameters need to be sent in to create a transaction? What parameters need to be sent in to ship that pair of shoes out to that customer? And then after that, last but not least, you're going to design your read-only queries. Queries don't change data. Queries are simply for fetching things out of the database and returning them in the shape that you want. And if you have built your SDL well, your queries become cake and ice cream in the summertime, and literally you get to pick and choose the fields you want that satisfy your data needs and your workflow in your API client. So this is a great Venn diagram, and I even wore my Venn diagram shirt, where the data you have and the data the client needs, you use GraphQL to create the bridge between those two, and the GraphQL is where you decide what data from what you have you are going to expose to each client that needs it. Summary. Let's summarize everything I babbled on about. Send your authenticated query to a backend with a thoughtfully designed schema where the depth and complexity are evaluated and the endpoint is non-standard before you start thinking that you are using GraphQL in a secure way. Here's where you can find me. I'm on Twitter pretty actively. My blog has got a fair amount of good stuff, and if you want to check out Sphere, which I know you all do, there's the URL. Thank you all very much for listening. Questions?
Thanks, thanks very much, Don. I think there's been a lot of good conversations going on the side here. Let's see, are there pending questions?
Don, quick question, if I may. When talking about the introspection, another thing that I've seen some of the GraphQL API backends do is kind of provide almost like a spell checker service when you send in a query, let's say user name, trying to basically figure out what the schema is if you don't have it. And it'll tell you, oh, I've got user, I don't have name. Did you mean first name or did you mean last name? Is it standard feature? Is it called something? Can it be turned off generally?
So once you disable introspection, that stops happening. Generally, backends, once you've disabled introspection, they stop being helpful in that Microsoft Clippy kind of way. So that's why another reason why it's one of the first steps, but also why it's helpful to have introspection on in your development environment, because you get that almost IDE-like prompting of the fingers you are using are too fat. Please try using skinnier fingers for typing your query.
Cool, thanks.
Any other questions? Any other questions? I don't see anything else on the chat. If anyone has any questions, feel free to unmute yourself and ask directly as well. Okay. If there are no other questions, well then let's give a virtual applause for Don. Thank you so much. That was a great, very, very useful talk. And thanks to Pablo once again as well. And thanks to everybody who's attended this session and participated in the fun and games and all of that. Our next event is on July 16, I believe. We'll be posting that up shortly in the next few days. Also, thanks for our sponsor, Buckrout, for the gift certificates. Artie will be in touch. And Amiran, I guess Don and Pablo will contact you guys if it's okay to make the slide decks available. We'll put them in our OWASP Vancouver archives. For more information on OWASP Vancouver and our events, you can check out our page on the OWASP Mothership. We have a page within that for OWASP Vancouver where we list all kinds of information about what is coming up next, previous presentations, and all of that. At this point, I'm going to stop the recording. We do have a YouTube channel. At some point, we'll start posting these back up on there. And yeah, thank you for attending, and hope everyone has a great evening. Take care.
A quick reminder, don't forget I posted a couple links for the surveys. Please fill that up. And yeah, again, thanks a ton, Don and Pablo. Really enjoyed both the talks.
Thanks, Judith. Thanks, everybody.